Very good evening. In this video, we are going to discuss about latest technologies implemented in power plant, that is particularly in coal-based power plant, that is in the area of boilers. The previous video we have been discussing about the vapor power cycle, which is governing the thermal power plant. In this video, we are going to discuss about fluidized bed compression boiler, which is the latest modified boiler at present in almost all the power plants, steam power plants. They are using this type of boiler. Normal conventional boilers, we have high pressure water tube boiler, that is a normal boiler, once through boiler. We may call it as once through boiler, that is Benson boiler or drumless boiler. The Benson boiler, there is no separate drum. It is a once through. At one end water will be entering, at the other end we will be getting the superheated steam. That's why it is called as once through boiler or Benson boiler. High pressure water tube boiler, that is normally used conventional power plants. Up to 20 years ago, we have been using this type of boilers. As the technological advancements, evolvements are taking place, we have modified combustion in the boiler at lesser combustion temperature. Whereas in the normal boiler, which I have mentioned here, that is Benson boiler or once through boiler, the combustion temperature, that is burning the coal inside the boiler, will be around 1600 degrees Celsius. If the combustion is taking place at a very high temperature, in the exhaust we will be getting oxides of nitrogen, huge amount of NOx emission, which will be leading to acid rain will take place. So in order to avoid the combustion temperature inside the boiler while burning the coal, we are going for fluidized bed combustion. So the oxides of emission, that is nitrogen, NOx emission, is directly proportional to temperature, combustion temperature. So we have to reduce the combustion temperature. So by reducing 300 400 degrees Celsius, we are reducing the emission of NOx, which is the dangerous to human being. So why it is called fluidized bed boilers, bubbling type fluidized bed boiler, that is BFB. It is called fluidized means the fluid flow is taking place, that is the coal particles will float over the serrated hot plate. If you look at the diagram, you can easily understand. From the bottom, we are supplying the hot air at high pressure with velocity. On the serrated plate, we are keeping the coal. Actually, the coal will not be kept there. The coal will be floating in the air. At the other end, we are supplying limestone along with the coal to reduce formation of sulfur oxides. That pollutant we are reducing here by adding the limestone. And over the grid plate, hot air at increased velocity is supplied. From the bottom, we are supplying the high velocity hot air, and coal and limestone, the mixture is being supplied. So the combustion is taking place. The coal is floating, that is, it is in bubbling stage. It is not seated, it is floating in the air. That's why it is called as fluidized bed. It doesn't have any bed, it is a fluidized bed. That means it is floating in the air. So the full peripheral circumference of the coal, 5 mm, 10 mm coal, gets exposed to the combustion, that is a flame, that is a fire, so that it gets easily converted into hot flue gas at lesser temperature. That is an important point we have to note here. not at 1400 degrees Celsius. Even at 700 to 800 degrees Celsius, complete burning of coal is taking place inside the boiler, the floating nature. So the hot flow gas, that coal burned ash, fly ash, all those things are escaped to the particular, that is primary cyclone separator, where the unburned, partly burned coals are collected and again sent back to the combustion chamber. The primary cyclone, how it works means by means of centrifugal force. When the hot, partly burned and hot flow gases are entering into the cyclone, while revolving inside the setup, the burned hot flow gas will escape. The unburned or partly burned coal particles will come down and it will again take place in the combustion. Thereby, we are minimizing the coal usage, that is minimizing the fuel, thereby increasing the efficiency. Here we got two advantages. One is we are reducing the combustion temperature, thereby reducing the NOx emission. Second, we are adding the limestone along with the coal. That limestone will reduce the formation of sulfur oxide. These are two advantages. If you talk about the principle, the solid coal particles are floating or suspended in the boiler surrounding or hot flow gases. So complete burning is taking place and hot flow gases are sent back to the primary cyclone, and where the filtering is taking place and exhaust gas is removed, particulate matter is removed. Another type of fluidized bed combustion is atmospheric fluidized bed combustion. That is the bubbling. Atmospheric means at atmospheric pressure. At normal pressure, the fluidized combustion is taking place. This uses the in-bed evaporator tubes in the bed of limestone, sand and fuel for extracting the heat from the bed to maintain the bed temperature. That is, the limestone along with the coal will be arranged as a bed for 1 meter to 1.5 meter deep, and pressure drop of 1 inch water, that is there is a pressure drop. By this type of arrangement, the fuel usage is reduced by 2 to 4 kilograms. But other things I mentioned, that is from the bottom we are supplying high velocity air, that is the velocity of fluidizing air is in the range of 1.2 to 3.7 meter per second. The coal size we are using here is up to 10 mm. This is called atmospheric fluidized bed combustion. The bubbling bed, as I have discussed, the coal particles are suspended under the advantages. Another type is circulating fluidized bed combustion. Here the coal size is 6 to 12 mm. The velocity at which we are supplying the hot air is up to 9 meter per second. These are the two changes. Coal size is increased, velocity is increased. That's why it's called circulating fluidized bed combustion boiler. The temperature of combustion is around 840 to 900 degrees Celsius. This is the diagram for circulating fluidized bed combustion. And other things, subsystems, fuel dash handling, draught system, feed water treatment, binary cycle, and cogeneration system. These are the some subsystems employed in power plant. This is an overview of coal handling power plant. This is ash handling. This is a simple layout of ash handling system. A draft, force dump, induced balance, and feed water treatment is required. Otherwise, scale will be formed inside the boiler tubes that will damage the boiler itself. We have to treat the water and we have to send to the boiler. Impurities, all those things should be removed. Otherwise, if you are not treating the water, the boiler tubes will get corroded like this. Okay, we have to treat the feed water. So with this, let me close this chapter, and in the next video we will discuss further on next type of power plant. Thank you for watching.